Okay, so we're going to have a short video about the states of matter. Anything you see in blue, I want you guys to write down. Otherwise, just pay attention and read what it's talking about. So we know matter is just anything. So stuff that makes up things that we see every day, right? Well, matter in itself can go through different phases of itself. When you have a solid, liquid, or a gas. Okay, so let's go through the three of them and just kind of talk about really what's going on a molecular level. What makes a solid a solid? Okay, so in solid, atoms are held tightly in place by the attraction to each other. So the attraction between particles within solids are very, very strong. Okay, so they can't really go far away from one another. And a lot of times these atoms have really specific arrangements, and it makes it so that if they were to somehow go away from that, they wouldn't be what they were. Okay, things like we see every day, types of materials like desks and metals and, chairs and tables and, anything solid, these atoms inside of them are very tightly held together. And so their kinetic and potential energy, it makes them vibrate in place. So it's almost like they're sitting still. But at the same time, because of how close they are, they do vibrate a little bit. So if you actually looked at a solid, an atom in a solid on a molecular level, you would see that these atoms would be almost just shaken ever so slightly, just kind of like how my mouse is doing. It's not very much. It's obviously not moving very fast at all, but it is moving. So there is something going on. It's not a completely stopped object. So the next thing is liquids, which they allow their particles to move a little more freely, not just anywhere and everywhere, but enough so that they can move way faster than a solid. So they have enough kinetic energy or moving energy to break out of their arrangement. So whereas a solid, it doesn't have enough moving energy. It just has just the right amount, so it'll stay where it's at. Where liquids, they have enough moving energy or kinetic energy so that they can go and fill the space of a container, right? So, and we won't do a demo for this, but a couple things to talk about is the melting point of something. So when the particles gain enough energy to break out of their arrangements, they melt. So that would be the melting point. So when it goes from solid ice to liquid water, the solid ice gains enough kinetic energy that it now can break out of their arrangement and turn into water. Okay, and the actual heat, that kinetic energy or that heat that is needed, that is required to change it from a solid to a liquid, that is the heat of fusion. Okay, so this is just the amount of energy that's needed, whereas this is talking about the point at which you have the amount of heat needed. So this is the point, and this is how much energy. Liquids can flow because they have enough kinetic energy to overcome the attraction that holds them together as solids. So the question is that if you've got solids, we got liquids, and what's the difference between a liquid and a gas? The thing is that the particles within a liquid, they still have some attractive forces between them. They're not completely separated. So it might be like if you can follow my mouse here for a second, it might be like solids look like something like this. This is about how far apart they are. Whereas liquids, they may look something like this. So there's still something like, think about opposite and opposites and attract, positives and negatives. They still can interact with each other if they're at that distance. But the farther you take them away from one another, so like this, and you're moving your mouse all the way across the screen, the farther you move them away, the less likely they are to be attracted to one another. Just like if you had two magnets, the closer they are, the harder they're going to stick together. The farther away they are, the more they're going to separate. So that's the difference, is that liquids are kind of the in-between scenario of solids to gases. They don't necessarily have to stay together, and they don't stay too far apart. There's still a force that brings them together. Okay, so now we talked about solids and liquids, and the last phase that we're going to talk about is gases. So gases have enough kinetic energy or moving energy to overcome attractions between each other. So they can float away. So the atoms within gases, they can float away from one another and not feel as if they have to be attracted to another atom. So for a gas, there's no fixed volume or shape. They can fill the container. They can do anything they need to. They're not going to have to be rigid enough to, like in the shape of something. Like there's no shape of a gas. It just fills in whatever area there is. And there's no volume for a gas either. No fixed volume, I should say. So when you go from a liquid to a gas, going from water to vapor, or I guess I'd say really a gas of gaseous water, H2O, that's called vaporization. And that makes sense because of the word vapor. You know what a vapor is. It's a what you would think of as a gas. And there's two ways you can do that. You can either evaporate it or you can boil it. And then the point at which a liquid becomes a gas, I mean, we had melting point, but the point when liquid becomes a gas, that's called the boiling point. And you guys can understand that if you're boiling, making some noodles on a stove, and you need the water to be boiling for the noodles to get warm enough to eat. Well, that is when the water that you put in the pot boils enough to where it can become a gas. But that point at which it does it, that's the temperature we're talking about. Okay, and the amount of energy that's needed to reach this boiling point is called the heat of vaporization. So vaporization, just think of vapor, gas, and that should be easy to understand. How much heat is required to get you to the boiling point and become a gas? Okay, so this is a really good drawing. I mean, so I guess it's really a graph, but we need to really talk about this because this is really going to help us understand what actually is going on. So the two axes we have are, if I can get my mouse to move here, energy and calories. Okay, so energy, and then we have temperature. Okay, so as you can see here, as you go up, right, you can keep going. The temperature is rising. The water heats as energy is added. So it's warming up. So this solid is warming up. Okay, and at some point it would change, but let's say we go ahead and go all the way up to water undergoing a liquid gas phase. So this right here is, there's some latent period, okay, some kind of energy that's required. See how it's still going up from 100 to 600 right here, 100 to 600 calories. So that means that there's some kind of energy that's needed to get through this phase, this transitional period. So it's not going to just bump right up to gas. That's why when you have a pot of water, not all the water just all of a sudden turns into a gas. It takes time for all of that water to eventually turn into a gas. And then once it hits that amount of energy, then as you can see, the temperature rises. During this period, there's no rise in temperature. But here, once the gas actually gets enough energy to where it can turn into a gas, you can actually have the temperature rise again. Okay. And that's all we'll talk about for today. Thank you, guys.